In this tutorial, we're going to take a look at the maximization problem in 7.1 in our books. It's a linear programming problem in which we want to maximize profits. So we're dealing with RMC Incorporated, and we are told that they make a fuel additive and a solvent base. They use 3 raw materials to make these, and we're told how much of each goes into each product. And we also are given constraints. So we're going to enter in all of this information and then use the solver function in Excel to figure out our product mix and determine what mix will give us the maximum profit. So the first question is, what are we making? Well, RMC makes a fuel additive as well as a solvent base. And again, we want to find the product mix of this. So what is going to maximize our profits? So here we'll enter the solution. We want to find the solution that solver will give us. And we're going to color code these 2 cells in yellow so that they're quick and easy to find. So then again, what should our mix be? How much should we make? What's going to maximize our profit? So our next line is going to be profit. And we'll enter in the contribution from each product. So fuel additive adds $40, and the solvent base, we're told, adds $30. Go ahead and center these to make them a little bit easier to read. And then this cell over here is what solver will calculate by substituting in the product quantities and finding the maximum profit. So this cell we're going to color code in green. This is going to be our profit. Next, we need to add in our constraints. And the constraints deal with the 3 raw materials that we have. Material 1, 2, and 3. And the book tells us that the fuel additive uses 0.4 tons of material 1, and the solvent base uses 0.5 tons. Fuel additive doesn't use any of material 2. The solvent base uses 0.2 tons. And then finally, the fuel additive uses 0.6 tons of material 3. And the solvent base uses 0.3 tons. So again, we need to finalize these constraints. We're told that we have a certain amount of each of these materials, and we have to work within these confines. So in this column, we know that we need, or we'll put our operation, we know that we need to be less than or equal to the amount given. So less than or equal to, and we have 20 tons of material 1, 5 tons of material 2, and 21 tons of material 3. Okay, now when we use solver, we are going to determine how much of each of these materials we're using. So we're going to go ahead and color code these 3 cells in blue. And we will see what we're working with. So before we can go on, we need to add in some sum product functions so that solver has something to work with. And these are going to go in the green cell and the 3 blue cells. So in the green cell, we're going to enter equals sum product of the solution, and that's going to be absolute, so you can lock that in. And then the cells on our left. So here it's going to be profit, close parentheses. Now, same thing down here for material 1 equals sum product, the solution, absolute, and the cells to our left. Okay. We can just copy those on down. And you can see that since we haven't entered any real values in here, we're returning all zeros at the moment. So now we want to use our solver function. So go ahead and put your cursor on the green tab or the green cell for profit, and then go up and click on the data tab. Once you do that, you can go and click on solver. You may not have the solver add-in yet. If you don't, you can go up here to this tell me what you want to do box, type in solver. It's an add-in, so you can check this solver add-in box and then click OK, and it should add that in for you. For me, it added it in all the way over here on the right. So click on that solver. And not sure what that error was, but the set objective, we want it to be this green cell, our profit max. That should have popped in there, but for some reason mine didn't. So you can just, if you have something strange in there, just delete it. And we want to click on this green profit box. Okay, so that's our set objective. 2, we are working on maximization here. So we've got that by changing variable cells. So this is the yellow ones. Those are what we will change, subject to constraints. So now we need to add constraints. So go over here to add. And then we need the cell references. These are the blue ones. We want less than or equal to. If it makes it easier, go ahead and line it up. Make sure you have the same symbol there. And then the constraint. Those are these values that we entered. So then click on OK. We've got our constraints in here, and our solver window is popped back up. Then you want to check this box here, make unconstrained variables non-negative, and then finally we need to select a solving method. So we want simplex LP. LP is linear programming. So click there, and then go on down and click solve. And over here we have a reports option. You can click on answer, and what that'll do is it'll pop up another window for us, or another page in our workbook for us that gives us an answer report. So click OK. And we can see now down here we have answer report 1, and then we can see our solution. So in order to maximize our profit based on $40 added for fuel additive 1, or for the fuel additive, $30 contributed for the solvent base, our max profit is $1,600, and that is saying that we made 25 tons of the fuel additive, 20 tons of the solvent base. Now we can see too that we're within our constraints. We've used all 20 tons of material 1. We've only used 4 of the 5 tons of material 2, so we have 1 ton of slack left. And then we've used 21 tons of material 3. So if you click on the answer report 1, we can see a lot of the same information. Solution for the fuel additive was 25. Solution for the solvent base was 20. Then if you go down here and look at the constraints, we see that we used 20 tons of material 1, so we have 0 slack, and that's said to be a binding constraint. The same with material 3. We used it all up, so we have 0 slack, and that becomes a binding constraint. Now material 2, we used 4 of the 5 tons, we have 1 left, therefore it's not a binding constraint. Now to go further into this example, now they suggest that we get $60 per ton, $60 profit per ton of the solvent base. So I typed in that 60, however, we're not sure that these calculations really changed, really did anything with this 60. So you need to click back on the green cell here, go up to data, click on the solver again. All of our constraints should be in here. We're still running a linear programming solver. Click on solve. It'll recalculate that. Then go ahead and click on answer report again, and that will give us another sheet in our workbook. So now we have answer report 2 as well. And we can see that now with this profit contribution of $60, our maximum profit is $22.50, and that's if we make 18.75 tons of the fuel additive and 25 tons of the solvent base. And that used 20 tons of material 1, so all of it, 5 tons of material 2, again that's all of it, so these are binding constraints, and it only used 18.75 tons of material 3, so we have 2.25 tons of slack, and we can see that this is not a binding constraint. Again, you can see all that in the answer report too. Same information, we see how much we make of each, and then we can see what constraints are binding and what are not. So again, in this example, it was just a simple linear programming example, profit maximization using the solver function in Excel.